Okay, we're live. Heat versus temperature. All right, thermal energy, heat, and temperature. Thermal energy, as we discussed a few slides back when I talked about different kinds of energy, is the energy of the random motion of particles. All particles, all matter, the particles are in constant motion. Atoms, molecules, they're always vibrating and rotating and moving around. Okay, and thermal energy is the energy of that random motion. Heat is the transfer of thermal energy from one system to another. Temperature is a measure of the average random kinetic energy. So it is not a measure of thermal energy, nor is it a measure of heat. Temperature is a measure of the average. Okay. So you think about, you have 20 cars driving down the highway. The average speed would be something like 80 miles an hour. But the total kinetic energy would be a wildly different number than that. Because remember, kinetic energy is 1/2 mv squared. Okay, the mass of the object multiplied by the square of the velocity, right, divided by 2. So thermal energy would be something akin to the speed of the cars, and temperature would be the average speed, right? And then heat would be, if one car ran into another and they changed their velocities. Okay. So a hot pebble would have a higher temperature than a cold boulder, because the pebble, it's hot. The average of the motion of the particles are moving faster, and thus the average of that kinetic energy would be higher. But it would have less thermal energy just because it's smaller and there were fewer particles. Even so, the zeroth law of thermodynamics says that heat will move from the pebble to the boulder until they have the same temperature. Okay? That's what the zeroth law of thermodynamics says, that heat moves from higher temperature to lower temperature until the temperatures are equal, at which point they are in thermal equilibrium, as they call it. All right, so how does thermal energy move from one place to another? There's conduction, convection, and radiation. Conduction is the movement of heat through direct contact. You touch the stove, heat moves from the stove into your hand. You set a hot coffee down on a counter, you pick it up, now the counter where it was sitting is warm. Okay? That's conduction. Convection is when the matter itself moves. Okay? So you look at the air above, a fireplace or above a fire, you can see the hot air is actually rising, and it can actually pick things up and move them, leaves, small bits of ash, things like that. Okay? That is convection. You also see this in, water as you heat it up. The bottom of the pot will be really, really hot, and as you heat the water, it will start to rise, and you'll actually get this sort of rolling motion as you get these systems of hot water rising and colder water falling down toward the bottom of the pot. So that's convection. Finally, radiation. You don't have to touch something or be in direct physical contact to transfer energy from one place to another. You can stand, in front of a fire and still get, nice and toasty warm because the fire is glowing. You got visible light coming out of the flames. You also have infrared light. You got lots of radiant energy coming out of the fire. And so those are the 3 ways that you can transfer energy. That's how the sun transfers energy to the earth, is through light and heat. Okay, so the 3 forms are conduction, convection, radiation. Conduction, you hold your hands in the fire. Convection, you hold your hands above the fire. And radiation, you hold your hands in front of the fire. All right, so heat is the movement of thermal energy. And as I said, we represent heat with the lowercase letter q, which is kind of confusing because we also use that to represent charge on a charged particle. So it's just something, there's only so many letters and we have to reuse them. So when we work with thermochemistry, when we're measuring these things, we are very often going to be measuring heat, the movement of energy from one place to another in the form of changing thermal energy, changing temperatures. Okay. So those are the things we care about: thermal energy, heat, and temperature. We will be measuring heat, usually by measuring temperature, and we'll have to know something about the thing whose temperature is changing. That will be calorimetry, and we'll spend a lot of time on that. But that's later. For now, we're going to move on and talk about work. So I'll see you in a few minutes to do that.